Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science 2023 Chemistry Paper 2 Foundation Tier. Question number 3 is on the chemical analysis. Some types of water contain dissolved substances. A student investigated the mass of dissolved substances in distilled water and in seawater. Figure 5 shows the apparatus. So you have an evaporating basin on top of a tripod with a sample of water and then heat being supplied, usually by a Bunsen burner. This is the method used. Weigh an evaporating basin, add a sample of distilled water to the evaporating basin, weigh the evaporating basin and the sample water, heat the water sample, weigh the evaporating basin and contents, repeat steps 1 to 5 2 more times, repeat steps 1 to 6 with seawater. So they're adding water and they're heating it, and once the water evaporates, they're heating it again to find out if there's anything left in the evaporating basin. So first with water and then second with seawater. So give one safety precaution the students should take. So because you're using Bunsen burner and glassware, the best would be to say wear safety goggles. Or you could say, because you're using a Bunsen burner, tie hair back. Any one of this will give you 1 mark. Second, question 3.2. The method used did not give valid results. Which 2 improvements could the student make to give valid results? So 2 improvements, you need to tick 2 boxes. Heat until the mass of the evaporating basin and contents does not change. I would agree with that. Leave some water in the evaporating basin. No, we don't really want the water. Record the results in a table and plot a graph. That's not actually going to help you to give a valid result. Use 25 centimeter cube of water for each experiment. Yes, that you want it to be controlled. Use a beaker instead of an evaporating basin. It's not going to make that much of a difference. A different student used a method which gave valid results. Table 2 shows the results. So type of water, test 1, 2, and 3. Distilled water, there's no dissolved solids. Seawater, first time is 0.31, 0.32, second time 0.27, third time. The student concludes that distilled water is pure water. Suggest why. Give one reason. Why? Because there's no increase in mass of dissolved solids. Because it's pure water, everything's got evaporated. So there is no dissolved solids. Tap water is potable. One step in producing potable water is sterilization. Why is potable water sterilized? To improve the taste? No. To kill bacteria? Yes. To remove dissolved solids, you would filtrate it, not sterilize it. So what is potable water? Potable water is water that is safe to drink. Chlorine is used to sterilize water. The reaction between chlorine and water is reversible. Complete the sentence. Equilibrium is reached when the forward and reverse reactions occur at the same rate. Remember, equilibrium is usually in a chemical reaction is given by this double-headed arrow. Forward and backward reactions. And when it's occurring at the same rate, then it's at equilibrium. The test for chlorine uses damp litmus paper. Complete the sentence. Choose the answer from the box. When damp litmus paper is put into chlorine gas, the litmus paper turns white. Chlorine is a bleaching gas, so it will actually turn it white. It won't turn it blue or green. Litmus paper can go either white or red, depending on what you're actually adding into. So litmus paper is going to go white with chlorine gas. It might change purple with an alkaline. There is evidence that adding fluoride ions to drinking water reduces tooth decay. Figure 6 shows the percentage of people showing tooth decay. So you have the percentage of people showing tooth decay on the y-axis, and on the x-axis you've got the age groups between 25 to 30, 34 to so in 5-year gaps. Water with fluoride ions is basically the dark columns, and the water without fluoride ions is the lighter columns. Compare the effect of adding fluoride ions to drinking water on tooth decay in people between the ages of 25 and 74. Use data from figure 6. So what are they asking us to do? Compare the effects of adding fluoride ions to drinking water on tooth decay between 25 to 74. So for the entire age group. So what happens to the percentage of people showing tooth decay when you add fluoride ions? Well, without fluoride ions, you can see that the percentage of people showing tooth decay is actually increasing, except for this age group. And so each box is 1, so that's 4%. So I'm going to write the values on the graph. This is what you would do in the exam as well for 4 marks. So that's 8%, and that's 14%, and that's 12%, and that's 18%. And if I change the color, let's say this is 2%, and that's 5. It's 5 again, 2, and 11. So what is the change in percentage? So between the ages of 25 and 35, without fluoride, it's 4%. With fluoride, it's gone down to 2%. So that's minus 2%. It's decreased by. Here, it's minus 3%. And that's minus 9%. And that's minus 10%. And this is minus 7%. Okay. So compare the effects of adding fluoride ions to drinking water. So without fluoride ions, the tooth decay is actually increasing for every age group except for 55 to 64. With tooth decay, the percentage of people showing tooth decay is actually decreasing for every age group. Right? You have to say, compare the ones with fluoride ions and without fluoride ions. And use the data from figure 6. So you should be referring to, say, for example, between the ages of 25 to 30, with fluoride, the percentage of people showing tooth decay decreased by 2%. For 35 to 44, it decreased by 3%. With 45 to 54 age group, it decreased by 9%, and so on. the highest decreased was for this age group, minus 10%. So here's a sample answer. If you write a couple of sentences, you should get at least half the marks here. So fluoride ions or fluoride reduces tooth decay in all age groups. This is what we observed in the graph. So the reduction in tooth decay using fluoride generally increasing with age. So what that means is it's gone from minus 2% to 3, minus 3, minus 9, right? And then minus 10, and this last one, it didn't decrease by so much, but generally it's actually reducing the percentage of tooth decay when you use fluoride ions. Tooth decay increases in 25 to 54 age groups, right? And 65 to 74 age group, while decreasing between 55 to 64. So the percentage of tooth decay is actually going up within the first, second, and the third group, and then it drops down, and then it increases again. That's what we mean here. Next point, fluoride has the least effect in the 25 to 34 age group. Remember, it was only 2% decrease. Right? But the greatest effect was in 55 to 64 age group, which was minus 10%. Right? Minus 10%. And using fluoride decreases tooth decay by 2% in 25 to 34 age group, 3% in 34 to 44 age group, 9% in 45 to 54 age group, 10% in 54 to 64, and 7% in 65 to 74 age group. I literally wrote down all the values that I wrote down on the graph above. Next question. Student A says that water companies should add fluoride ions to all drinking water. Student B disagrees. Suggest one reason why student B may think that fluoride ions should not be added to all drinking water. When we say all drinking water, would you really want them to add fluoride to bottled water that we buy? Not necessarily. So maybe for the tap water, why? Because we want that to be clean, free of bacteria. But mineral water that we buy from bottled water should be clean without bacteria. So they don't really need to add fluoride. But would you want to add them? We don't really know the effect of adding too much fluoride into water. Maybe there could be side effects. So there's a number of reasons why people might not want it to happen. So any of these points will give you 1 mark. Could be a risk to health, could have side effects, could decolorize water. People should be able to decide for themselves. Right? Any of those points will give you 1 mark. That brings us to the end of this video. Thanks for watching, and I will see you in the next video.